This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the February-March 2024 Cambridge Paper 1 Pure Mathematics from the 9709 A-level syllabus. This question here is about series. We're told about an arithmetic progression is such that the first term is 6 and the 10th term is 19.5. Find the sum of the first 100 terms. Okay, so now the sum of the first n terms of an arithmetic progression is given by the formula n over 2 times a plus n minus 1 times d. Now, this is, the first term is called a. U1 is the same as a. That's what a stands for. Okay, we know U10 is 19.5, the 10th term, and we know the formula to find the nth term of a series is given by a plus n minus 1 times d. All right, so with all of this information, we should be able to do or to find the sum of the first 100 terms, because we know what a is, we know what n is, it's 100. We have to find what d is. So we can find d from this information here. So I can say that the 10th term, a plus, that's going to be 9d, 10 minus 1 times d must equal 19.5. And I know the first term is 6. So I've got 6 equals, 6 plus 9d equals 19.5. So I have 6 plus 9d equals 19.5. So 9d is equal to 19.5 minus 6. So 9d is going to be, that's going to be 13.5. So d is going to be 13.5 over 9, which is like 27 over 9. 26, 13.5 over 9, which is going to be, 27 over 18, what am I doing? Multiplied by 2. 27 over 18. Okay, which when you divide them and 9 goes into both of them, that's going to be 3 over 2. So the common difference is equal to 1.5 or 3 over 2. Okay, so once we have that, we can find the sum of the first 100 terms. So the sum of the first 100 terms is going to be n over 2, which is 100 over 2 times a, 2 times 6, plus n minus 1, which is 99, times d, which is 1.5. Okay, so that's going to give us our answer. So we have 50 times 12 plus 99 times 1.5. That gives us answer 8,025. 8,025, and there's the answer to part A. All right, so the key was to find what A is by using the information given and then stick it into the formula for the sum of the first 100 terms. Okay, so 100 over 2 times 6 plus 99, because 100 minus 1 times d, which we found 1.5. So there's A done. Now for B. It says a geometric progression, A1, A2, A3, and so on, is such that A1 equals 24 and the common ratio is a half. The sum to infinity of this geometric progression is denoted by S. The sum to infinity of the even numbered terms, A2, A4, A6, is denoted by SE. Find the values of S and E. Okay, so let's start with the first one, S. Now we know the sum to infinity of any geometric series is given by the formula A over 1 minus R. Now what is the sum to infinity? It's the sum of a geometric series when the common ratio is magnitude is less than 1, such that the subsequent terms keep getting multiplied by a number that's smaller than 1, so the terms get smaller and smaller and smaller and smaller. So as you go along, you end up getting really, really small terms. When you add them together, the ones further on don't make any much difference to the actual sum, and the sum converges to a particular value. So this only happens when the common ratio has a magnitude less than 1. So the first case, we want to find the value of S. S is going to be A over, now A is the first term, which is 24, over 1 minus R, and R is a half. So 1 minus a half is a half, so it's 24 divided by a half, which is 24 times 2, which is 48. That's pretty simple, so S equals 48. That's the first answer. Then it says SE. Now, for the second sequence, the first term is A2. Now, let's write out what A1 is and A2 is and A3 is. Okay, A1 is 24. To get to the next term, we multiply by half. That's going to be 12. To get to the next term, we multiply by half. You're going to have 6, and so on. A4 would be half of that 3. A5, 3 over 2, and so on. You keep dividing by 2 each time, multiplying by half. So we're concerned with the terms which are even, the even positions. So we have, sorry, what am I doing here? A1. So U1 and U2 and U3, second. Mad. Okay, so U3 and U4 and so on. Okay. Let me I'll just do that again. It's just went a bit haywire there. Sorry about that. So we know that the first term is 24. The second term is 12. The third term is 6. The fourth term is 3, and so on. It continues, halving each time. So we're concerned with the terms in the even positions, which is this position and this position here. Okay, so for this sequence, which will be basically 12 and 3, and then 3 over 2, then 3 over 4, and so on, we need to find the common ratio. Now, the common ratio is found by taking a term and dividing it by the term before it. So 3 divided by 12, which is 1/4. So for this second sequence here, the common ratio is 1/4. And the first term is 12. Okay, so like the second term of our first series. So SE then is going to be given by A over 1 minus R, which is 12 over 1 minus 1/4, which is 12 divided by 3/4, which is 12 times 4 over 3. You divide by a fraction, you multiply by its reciprocal. They cancel out, so you're left with 4 times 4 is 16. So SE is equal to 16. So we have SE is 16, and we have S equals 48. And that concludes this question. It's a pretty simple one, actually, to be honest with you. I was expecting something a bit more difficult by the time we get to question number 8. But anyway, we have, I think, 2 or 3 questions are remaining. And it's been quite straightforward so far, quite plain sailing, this paper. Anyway, other questions from this paper you can find in the playlist that will appear in this region over here. Other questions from the topic of series you can find in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video here, which will tell you how to use my channel to find what you're looking for. Thank you for watching, and see you soon.